Okay, so this is a quick test of our program. Essentially, the program that I'm testing is this one. I'm gonna send that to you. So essentially, first uh, we're loading X5 we're loading 5 into X5, 1085 into X6, mainly just to have a three digit hexadecimal number. Then we use a loop to start. Sorry, first what we do is we check if x5 is greater than x1. Now at the beginning, since x1 doesn't have anything, is gonna go directly to the loop because x5 is greater than x1 because x5 has 5, x1 has 0, so 5 greater than 0, we're gonna go to the loop. Now in the loop, we're gonna shift our value of x6 4 times. We're gonna add into x7 1, which is going to be our control variable or our I in a for loop. Then we're going to check if x7 is less than x5. So x7 is 1, x5 is 5, so 1 less than 5. We're going to go back, we're going to shift. Essentially, we're going to shift this 5 times to we're going to shift this number 5 times to the left, mainly for demonstration since we don't have load upper immediate. Now the next part, what we have add upper intermediate x5. So essentially we're gonna have our control value, so x5 be our end, and we're gonna have load another three-digit hexadecimal number into x8, so that way we can go ahead and load that in later into x6. Now we're gonna start x7 to 0 again. Then we're gonna have a second loop. First, we're gonna shift 4 to the left. We're gonna add 1, and we're gonna go 1 to the sorry. Then what we're gonna be doing is we're gonna move 1 to the left. Uh, sorry. Well, we're gonna check if x7 is less than x5. Okay, it's not. It is. Then we're gonna go back to the loop. Essentially, once our x7 value reaches 2, we're gonna break out of the loop. Then we're gonna load the first. So we're gonna load this number into the byte. Sorry, into bytes. Well, into the hex number. So we have 8 hex numbers. So we have 5876. We're gonna load this into 543. Then we're gonna load the number once. We're gonna load the number 17, essentially just to have two lower hexadecimal numbers. Then what I want to have is I want to just get a random address for memory. Then what I'm gonna be doing is I'm gonna store x6 into 0 times, sorry, into x12, so 4 with an offset of 0. Then I'm gonna load a byte with x12 offset of 1 just to get the second byte of x6. Then x12 load half. Essentially, I just want to get the first half of x6. Then I just add the value of sorry I just add the value of 8 into x13 to go to the next address block. Now I store a byte into that address block, so into the third byte of that address block, so byte 2, and then I store the first half in of x6 also in that same memory address. Then I just load that word into register x28 just to test that it has been loaded correctly. Then I just jump to the start and assign my x1 to be 92, essentially my return address. Now, what I'm going to be doing here is in my start label, I'm going to be doing the same. I'm going to be loading 5 into x5, 1085 into x6, and okay, now x1 is already loaded with a value, which in this case it's 92, which is the line where we have our jumping link multiplied by 4. After that, what we're gonna be doing is our branch greater than equal. It's not gonna work because x5 is less than x1 in this case. So we're gonna go into jump and link register. So jump and link register, I want to save this address. So 4 times 4, that should be 16. And I want to store it into x14. I want to load, so I also want to load go to address what it's in x1, which is 92 offset 4. So it would be the instruction just after the jump in link. Now, then I'm gonna test. This is pretty much just a bunch of testing functions just to test shift left, shift right, and also to test branch not equal. And that should be the program. Now I'm gonna go into the demonstration. Okay, so let's go here. Okay, to test the program, so what we're gonna be doing. So I created a .hex file, which is with the instructions already translated into hexadecimal. Now, in this case, to load in VS Code is a little bit easier because once you pull it from the Venus compiler, essentially what it's gonna do, it's gonna add a 0x at the beginning, and you can just remove it with Control F and replace all being empty. Okay, so the next part is loading the image. So my file is called addy.hex. It's very important that we have our file as .hex. We open it. We select that we want the instructions to be in hex, and we click OK. And as you see, it automatically populates for us, so we don't require an input here to work it out. Now let's go ahead and test one by one. Let me just make sure that my program counter is 0. It is 0. Okay. So first instruction, loading x5 into register, loading 5 into register x5. So let's go to a register file. Go ahead and push our clock once. We already moved into the next memory address. Then 1085 into x6. Okay, let's go to our register file, register x6. Okay, now next one. So the next would be sorry, let me just go ahead and pull up my instructions again. Okay, so the next part is checking if x5 is greater than x1, which should be true. Okay, now let's go to my instruction memory. Let's load that instruction. So if you go to the processor, you're gonna see that the branch is on, so meaning that we're using a branch instruction, and bints is essentially the output of this mux. This mux selects based on bits 12 to 14, so essentially the function 3. What is which instruction is it going to execute? Are we going to check equals? Are we going to check not equals? Are we going to check less than? Are we going to check greater than or equals? Now in this case, we're selecting 5 out of 5, so essentially input 5 here, which is less than, greater than, or equals, which is our branch instruction. Okay, so now in this case this yields true. Now the offset that we have is the offset of the loop. So loop should be 2 instructions ahead. So let's go back to our instruction memory. So we're just gonna see the jump here. Okay, so it jumped 1 instruction, so now it's in the loop. If you look, the program counter updated to be 10, so instruction 16. Alrighty, so the next part, what we're gonna be doing is, so the instruction that we have first inside the loop, it would be to shift to the left what we have in x6. So let's go ahead and take a look into that. Okay, so shift it once. Then the next instruction that we have inside the loop would be adding 1 to x7. Okay, that's good. Then we're gonna go and pull out a branch. Okay, so let's go ahead and take a look to see if it branches. Okay, our branch is off right now. I take the clock and it works. So it's also x7 is less than x5, so the less than should be on. That's good. Alrighty. So the next part should be just going back to loop, which should be if I'm not mistaken, this instruction here, this one. Okay, so we go back, we shift. So, okay, so in the meantime, I'm not gonna go back and forth just to view the changes. I'm just gonna stay in the register file, which is where the important stuff is happening. So we shift 1, 2, 3. Okay, so we shifted all the way to the far left. Now x7 is 4, so we're gonna add 1. Then what we're gonna be doing is we're gonna compare. So the next instruction should be a branch, and we're gonna check if x7 is less than sorry, we want to check if x7 is less than x5, which in this case it's not. It's greater than, sorry, it's equal in this case, as you may see by the mux here. So we are not gonna execute that part. So we're just gonna keep on moving with the remaining instructions. So, sorry about the messiness of the video, but it's a little bit hard to work with Logisim. Okay, so after we exit that loop, what we're going to be doing is we are adding uh, 2 into x5 just to get another control. Okay, okay, and then we're adding into x7, sorry, into x8, we're adding 1942. 1942 is essentially just for us to have a 3-digit hexadecimal number to work with. Alrighty. Now the next part, it's gonna be returning x7 to be 0. Then we're gonna be checking if x7 is less than x5. Okay. Okay. Then we can see that the branching returned. Now in this case, the branching has been returning us, so that way we can be changing. Essentially, we're doing exactly the same thing as we were doing before. Now, except we're working with x8 and x5 and x7 to start shifting x8 to the left. Okay, and we have shifted it successfully. Now, if you look here, right now we are at the branch instruction. This would usually, you see them start with FE. It's a little bit easier to identify once you're reading hex if you read it that way. So if you take a look, we turn on our branch, but right now, because what is selected is equals, it's not going to execute since we need to have the value of less than, and less than is 0. So this part is gonna become 0 as well. Righty? So now what this is gonna be, okay. So now we're just gonna continue with the program as normal. So PC is just gonna increase by 4. Okay, so we have then the next instruction after our branch less than, it would be ORing x into x6. What is in x8? That's in order to load those lower bits into x6. Okay, and if we go to a register file, so if you look at x8, so we have 796. Okay, after that 1 clock tick, we have that loaded into x6. Okay, the next part is we're gonna OR immediate. So what is in x6? We're gonna OR it with 17, which 17 should be 1, 1. Okay, so that's loaded in. Then what we're gonna be doing is okay, then we're gonna add into x12. we're gonna add 4, mainly so that way we can get an address to work with in order to do the stores. So the store after this, what's gonna happen is, so we're gonna store the whole word into address 4, meaning our second word in our data memory. Okay, so let's go here and okay, we need another tick. There you go. So it's loaded already in. The next part should be loading a byte into X10. Okay, into X10 we're gonna load 96. Okay, so if you look over here, we have 96 sign extended to get the matching, sorry, so that way we can work with the sign later on. Okay, and it's already loaded into X10. Now we're just gonna load half of that word into X12. Oh, sorry, wrong memory. 12. So it should be 9611 sign extended, which is FFF, all the F's and 9611. Okay, we have it here. Let's go back to our register file and let's just go ahead and tick the clock to load it. Okay, good. Now the next part, okay, load half. Then what we're gonna be doing is testing the stores. So we're gonna load 8 into X13 to have a control to load into our second block of data memory. Okay. So we're gonna load we're gonna load a byte and we're gonna load it offset 1. So pretty much we're gonna load 96 here into A2. So let me just double. Oh no, my mistake. Sorry. So what we're gonna be doing is we're gonna store. Sorry, we're gonna store the third byte. So D7. Okay. Okay, that's it. And we're gonna store the first half, which is the 96 and 11. Okay, that's good. Then we're gonna load the whole word. So this, we're gonna load it directly into register X28. And mainly just to let you know, right now I'm using arbitrary registers. I know that there's conventions, but mainly this is for testing purposes only. Okay, so let's look at X28. Okay, so we got it here. Now the next part is jump and link. So jump and link, we're gonna save X1 into the return address. So we're gonna save X1 into X1. We're gonna save the current program counter. So which is 5C. Then the next part that we're gonna be doing is we're gonna be jumping to instruction 0. If you look in instruction memory, the highlighted memory is the first instruction in memory. So we're just gonna do again loading X5 into 5 into X5, 1085 into X6. Then we're gonna check if X5 is greater than X1. In this case, no, because X5 is 5 and X1 is 5C or 92, which is the return address of that jump that we did before. So if you look over here, we also updated the program counter to go back to the start. And we also have the branch instruction right here. Let me just turn it on. Okay, so the second part didn't light up, so everything's working fine because the one that we need to test is BGE. So equals is not on, greater than is not on. So this input is the one that's selected because this input is not on. The output's not on as well. Okay. Now the next part that we're gonna be working, it would be jump and link register. So we're gonna save our return address in X14. We're gonna use the address that we have in X1. We're gonna add an offset of 4 so we can go after our previous jump in link. Okay, so let me just demonstrate just to show you in what is an X14 now. Okay, so that loads 12, which is the address of the jump and link register, and the instruction memory. If you take a look here, so this is the address. So the address of the previous jump and link, we're going one after. Now the next part that we're doing is we're testing and. So and the instruction that we're testing if we're testing just double check. Okay, jump in link X6 and X5. So when we're ending, we should be getting just X5 because pretty much the rest of the bits are just 0. Okay, then let's load that instruction in and let's go directly into our register file. We're storing that result of AND in X15. Okay, so it's 5. Now we are also ANDing immediate 5 with 57, and we're storing it in X16, which should still be 5. Okay. Wait, no. 57, so 7. Let me just pull up an AND calculator here just to double check my results. Okay, 5, 57, calculate. Okay, sorry, my mistake. It is correct. It is 1. Okay, then we're testing SOAR. SOAR, we're testing X5 and X6. Let me just go and pull my SOAR calculator. So we have 5 and 1805. Sorry, 1085. Then we calculate. So the result that should give us in hex would be 438, and it would be loaded to X17. So, okay. Let me just double check something. Oh, my mistake. So it's sub X17, X5, X6. So we're subtracting 5. Sorry, I put sub first, my mistake. So we're subtracting from 5, we're subtracting 1085, which the result should be 5 minus 1085 should be minus 1080. So minus 1080 to okay. Let's pull to calculator. Okay, so that should be so 32 bits and minus 1080. Okay, so FFF, and we have okay, it's working. Well, let me just double check with my okay, 32-bit ALU. Okay, it's working. Okay, then the next part that we have source. So for soar, we have, okay, so we have the 438 as I mentioned before. Then I have the with, so I have it with -1, 5 with -1 now. Which, let me just double check which one did I use. Hmm, so, actually, so, okay. Okay, calculator. Um, okay, okay, decimals. We have 5. Wait a second. Decimal. Okay. No, yeah. It's giving the correct result. I don't know why the calculator that I'm using is giving weird results, but it's probably because of it's handling less bits. Now the next part, it would be testing regular add. So I'm adding 5 into X, where I'm adding X5 and X6, so 1085 plus 5, which should be 1090. Now if we go to our ALU, we should be getting 1090 here, as you may see. Oops, there we go. The next part that we're going to be testing is shift left logical. So in X21, so for this one, I'm using X6. So let's go to the register file. Let's go to X21. Okay. Oh, sorry, I'm using X20 first. So in X20, what I'm doing first is I am, okay, so that's the add. Oh, sorry, no, it's X21. We are shifting 80, so 87A, we have that's what we shift that 5. And then what we have after that, we are gonna shift that what we have here, we're gonna shift it right 4. And we're gonna do the shift arithmetic 4 as well for in X23. Then what we're gonna be doing is in X24, in X24 we're gonna shift X6 by 4 to the left. Then in X25 we're gonna shift this one to the right by 4. And in X26 we're shifting that right by 4. The next part that we're gonna be doing is we're gonna be doing a branch not equal. So essentially pretty much the branch not equal that I'm testing is x0, x6. So if x0 is different than x6, I'm just gonna go to start. So it should go back to the start. There you go. Alrighty. Hope you like this demonstration, and please let me know if you have any questions.